So how exactly do you fix semantic mismatch in a RAG system without totally destroying your system's performance? Honestly, it's the ultimate engineering balancing act. You want your retrieval-augmented generation system to be incredibly smart, right? You want it fetching the exact right context. But the second you try to make it smarter at runtime, boom, you introduce that dreaded loading spinner. Your users are just sitting there, tapping their fingers, wondering if the AI fell asleep on them. So, how do we actually solve this? Welcome to today's Explainer. I am so absolutely thrilled to have you here. Today, we're tearing down a really complex architectural challenge and looking at a genuinely clever solution straight from a phenomenal open source resource. We're going to explore optimizing RAG latency by comparing two specific pre-retrieval enhancement techniques, HyPE and HyDE. If you are focused on building real-time, highly responsive AI applications, well, you're in the exact right place.
All right, here's our roadmap for today. 1. The semantic mismatch problem. 2. Enter HyPE. 3. HyPE versus HyDE. And finally, 4. Minimizing RAG latency. Let's get moving.
Starting off with Section 1, the semantic mismatch problem, or the hurdle of getting the right answer quickly. Okay, let's dive into this core issue. The root cause of so many bad RAG outputs is this semantic mismatch between user queries and document chunks. Think about it for a second. A user types in a super brief conversational question like, how do I reset my password? But your database? It's filled with these dense, factual, multi-paragraph technical manuals. Linguistically and structurally, a short question looks completely different from a long, detailed answer. And because of that semantic gap, standard retrieval systems really struggle to match the user's quick query with the correct, dense chunk of information. To fix this, developers historically just added extra steps right at the moment of the query to bridge the gap, but doing that introduces our biggest enemy, latency. Which brings us right to Section 2, Enter HyPE, and the brilliant concept of shifting the computational effort. To solve this whole mismatch issue without dragging down the system, the source documentation introduces us to HyPE, and that stands for Hypothetical Prompt Embedding. Now, what's genuinely fascinating here is how HyPE fundamentally flips the script on exactly when the heavy lifting happens. Instead of waiting around for the user to ask a question, HyPE is proactive. It pre-computes hypothetical questions for each and every document chunk. And crucially, this execution happens entirely during the indexing phase, way before the user ever even touches the application. By designing these hypothetical questions to capture the core concepts of the text chunk, HyPE completely transforms the retrieval process. Instead of trying to awkwardly match a user's short question to a document's long answer, it shifts everything to a seamless question-to-question matching system. Let's actually walk through this brilliant workflow step by step. Look at Step 1, the indexing phase. The system reads your documents and uses an LLM to guess, okay, what questions does this specific text answer? Because all of this happens up front, it brings us to the massive, absolutely crucial benefit in Step 2. We completely avoid LLM calls at runtime. All the hard work, it's already done and stored, which leads perfectly into Step 3, fast question-to-question matching. When the actual user query comes in, the system just matches their real question against those pre-generated hypothetical questions. It's literally an apples-to-apples comparison, which drastically improves retrieval accuracy while keeping latency practically at zero. Moving on to Section 3, HyPE versus HyDE, a head-to-head comparison. Now, you really can't fully appreciate HyPE without comparing it to its very famous counterpart, HyDE, or Hypothetical Document Embedding. Both of these techniques exist to enhance RAG by tackling that semantic gap we just talked about, but their approaches are totally different. HyPE generates hypothetical questions, and it does it at indexing time. HyDE, on the other hand, does the exact inverse. When a user submits a query, HyDE generates hypothetical answer documents right then and there, at query time. Let's break down the three most important features of this head-to-head matchup. First up, timing. HyPE happens at indexing time, while HyDE happens at query time. Second is efficiency. Because HyPE operates during the indexing phase, it entirely avoids runtime LLM calls during retrieval. HyDE, conversely, requires a brand new live LLM call for every single user query just to generate that fake document. And third, the focus. HyPE is all about question-to-question matching, whereas HyDE generates a fake answer on the fly to do answer-to-answer matching against your real stored documents. Like with any major engineering decision, we've got architectural trade-offs here. We're definitely not saying one is universally bad and the other is good. As the source material points out, HyDE is incredibly flexible. It's kind of like a Swiss Army knife. Because it generates a response on the fly at query time, it is highly adaptable for diverse, wildly unpredictable queries that you honestly couldn't possibly anticipate during indexing. However, if your number one priority is pure speed, HyPE is your race car. Its pre-indexed approach is built specifically for demanding real-time applications, where a user simply cannot and will not sit around waiting for a live LLM generation step just to fetch the right documents. And that brings us to Section 4, minimizing RAG latency, the ultimate optimization benefit.
If your ultimate goal is to minimize RAG system latency, you really have to ruthlessly audit your pre-retrieval enhancements. The source highlights some very common traditional query time bottlenecks: query rewriting, query expansion, query decomposition, and of course HyDE. So what do all of these actually have in common? They force the system to literally think about how to search before it actually executes the search. They require live LLM calls right at the moment of the query, and that directly spikes your latency.
Which leads us to this incredibly powerful quote summarizing the whole solution. By shifting the computational effort to indexing, HyPE ensures faster and more precise document retrieval. By putting in the heavy lifting to generate those hypothetical questions beforehand, you're essentially pre-computing the semantic bridge. The end result? Your high retrieval accuracy is totally maintained, but your runtime latency drops off a cliff. It is just a massively efficient question-to-question matching process. So, I want to leave you with a question to reflect on regarding your own architectures. Are your RAG systems truly built for real-time performance, or are they stuck waiting around on query-time LLM calls? If latency is the biggest enemy you're battling right now, it just might be time to stop fixing the query at runtime and start pre-computing the questions at indexing time. Just a quick wrap-up note, the insights from today's explainer come directly from Kalyan KS's genuinely incredible GitHub repository, the RAG Interview Questions and Answers Hub. Specifically, he's put together a brilliant implementation of over 25 must-know prompt engineering techniques. And as the repo notes, knowing these techniques is absolutely essential for data scientists and AI/ML engineers working with LLMs, RAG, and agents. I highly encourage you to go check out that hub to dive deeper into these implementation strategies. Thank you so much for joining me for this explainer. Keep optimizing those architectures, and I'll catch you next time.